So we are going to understand today the memory representation of graph. Uh, in memory, the graph can be represented in two ways. It's either the matrix or either the list format, for which we are going to use the linked list basically. So this is called as adjacency matrix and adjacency list. So in detail, let's understand what is adjacency matrix and what is adjacency list. So the first is adjacency matrix. We all know this, that graph is a collection of nodes, vertices and edges, and it basically has n number of nodes. Let's assume that n stands for the number of nodes in the graph. Okay, so we are going to have a matrices of n into n. Means if suppose we have 5 nodes in a graph, it means we will have a matrices of 5 into 5. Okay, and AM stands for adjacency matrix. And wherever the nodes are connected to each other, in whichever direction the nodes are connected to each other, if your nodes are connected to each other, there we are going to mention 1 in your matrices. And where the nodes are not connected to each other, if an I and j, that is your row and column, if your two nodes are not connected to each other, we are going to mention in the matrices 0 at that particular location. So remember, we are going to have a matrices of n into n, and then if two nodes are connected to each other, we are going to represent it as 1 in our matrices, and if it is not connected, then we are going to represent it as 0. So let's see how to make an adjacency matrix for a particular graph. Let's take an example of a particular graph right here. So here is the graph that we have. Now let's prepare our matrices. We have basically 4 nodes, so 1, 2, 3, 4. So our matrices is going to be 4 into 4. And the name of our edges are A, B, C, D. So let's go for it. We are going to make a 4 by 4 matrices. A, B, C, D. That's going to be our column. And then our row representation. Sorry, this is going to be a row representation and this is going to be a column representation. So here we have a 4 by 4 matrices, and we have mentioned our node names also right there, A, B, C, D respectively. Now as they say, we have to mention if the nodes are connected. If the nodes are connected, we are going to specify 1. If the nodes are not connected, we are going to specify 0. So let's see over here. Let's go for it. A to A. A to A. Is it connected? No, there is no cyclic edge we see over here. So A to A is basically not connected. So if it's not connected, we have to mention 0. Now let's see A to B. A to B is connected. Yes, there is a directed graph going from A to B. So basically A is connected to B. So it's connected. So we are going to specify 1, because it said if specify 1 if it is connected. Then we are going to see the next edge, A to C. From A to C, we have to check the direction also. C to A is connected. The direction from C to A is there, but the direction from A to C is not there. So basically the connection is not there. So you all are going to mention 0. A to D, is the connection there? From D to A, the connection is there, the direction is there. It's pointing from D to A. But the pointing from A to D is not there. The pointing in this direction is not there. So A to D connection is not there. So we are going to mention out 0. Let's go for B. B to A connection is there, B to A connection is there, B to A connection is there, no it's not there, so we'll mention 0. B to B connection is there, no it's not there, so we'll mention 0. B to C connection is there, yes it's directed, so we'll have 1. B to D, no connection. Then we'll go to C. So from C, do we have C to A connection? C to A connection, yes we have, so 1. C to B, no, 0. C to C, 0. C to D, 1. Now last and final one, that is D. D to A. D to A connection is there, yes it's there, so 1. D to B, no. D to C, no, and D to D, no. So this is our adjacency matrix, very easy to make, and that's how we are supposed to make it. Now the next memory representation is basically adjacency list. This representation is done with the help of our linked list representation. This is a very simple memory representation. Again, let's consider the same graph that we could. So here is a graph, and now we have to represent linked list. So first we'll consider our node A. We have to consider all the 4 nodes. So first we'll consider our node A, then we'll consider our node B, then C, then D. So we have to make a list. Of connected edges. So we are just supposed to mention in this list, maintain the list to which A is connected to. So we have to make a list, adjacency list. Adjacency stands for the adjacent node basically. So if it is connected to the adjacent node, then we have to mention in this particular list. So first we will find out what is A connected to. A is connected to B, yes it is connected. Is A connected to C? No it's not. C is connected to A, but A is not connected to C. The direction matters, I told you. So A is not connected to C. A is connected to D? No, it's not connected to D too. So it's only connected to B. So let's mention that it's connected to B. Is he connected to himself? Is there any cyclic edge to himself? No, it's not there, so he's not connected to himself too. So next is B. Is B connected to himself? Cyclic edge is there to B itself? No, it's not there, so it's not connected to himself. Is B connected to A? No, it's not. The direction is opposite, it's from A to B, so B to A there is no connection. Is it connected from B to C? Yes, it is connected, so let's mention B to C. B to D, no connection available. Then we'll go for C. Is it connected to himself? No, it's not. Then is it connected to A? Yes, it's connected to A, so we'll mention A. Then is C connected to B? No, it's not connected to B. Is C connected to D? Yes, it's connected to D, so we'll mention D right here. After that, anything else left? No, nothing else left for C, so we'll go to D. Is D connected to A himself? Is D connected to himself? No, he's not connected to himself. Is D connected to A? Yes, D is connected to A, so we'll mention A right here. Is D connected to B? No, it's not. Is D connected to C? No, it's not. So we are done with our adjacency list representation. It is basically a linked list representation, and we have to mention for each and every node, we have to mention the connected nodes which are there, just the connected nodes. That's it. That's about your memory representation part.